Okay, so today we're going to talk, you've learned all this stuff. You've learned how to factor quadratics. You've learned how to complete the square to solve for the zeros. You've learned how to, and you've learned that the zeros are where a parabola, either this way or this way, touches the x-axis, right? You've learned how to use the quadratic formula when you can't factor it easily. You've learned the importance of the discriminant in terms of telling how many solutions you have to a problem. Now it's time to actually use this information to actually, on real life problems. And one thing that you'll notice that with these real life problems is that they will never ask you in the terminology that I have taught you up to this point. I have taught you parabola. I have taught you vertex or vertex. I have taught you axis of symmetry, where the parabola is symmetrical, right? I have taught you finding the zeros, finding the x-intercepts, finding where it crosses the x-axis. It never will ask that. It will never say find the zeros or find the vertex. It will ask questions like find the highest point that the ball reaches, or how long before the ball hits the ground. You have to then translate that into, oh yes, find the vertex, or find the zeros, find where it crosses the x-axis. That's your job, is to simplify, to understand what they're asking. Every question you get now with these, you know how to solve. All you have to do is figure out what they're asking. They're always going to be asking about either the zeros or the vertex or the time, right? The time it takes for it to hit the ground or whatever. So let's see what this says. It says the height in feet of a golf ball, right, that is hit from the ground, meaning it's at 0, right? Its height when it starts is at 0, can be modeled by the function f of x is equal to negative 16x squared plus 96x plus the initial height. What's the initial height? Remember this formula? It's negative 16t squared plus vt. So that means its upward velocity is 96 feet per second. And plus the last one is its initial height. Remember its starting point? It's s. What's its starting point? It's from the ground. It's 0. That's why it's 0, because it's starting on the ground, right? Okay, so that makes total sense. It also makes sense that it's negative. Is that going to be an upward or downward? I mean, is it going to be a happy face or sad face? Yeah, sad face. Every time I've hit a golf ball, it's gone up and then it came down eventually, right? But there could be some exceptions in John's world and Jason's world. But okay, so it can be modeled by that, where x is the time in seconds after the ball is hit. Find the ball's maximum height and the time it takes to reach that height. Then find how long the ball is in the air, and then graph the parabola. So there's a lot of things there that they're asking. So you kind of have to keep in mind. Let's see. I know a lot of these pens don't work, but so number one, they're saying 1, find the ball's maximum height, and 2, find the time it takes to reach that height, and 3, find how long the ball is in the air, and then 4, graph it. Okay? So let's do it. So what are they asking for? For the first question, find the ball's maximum height. We have a quadratic equation, and they're asking for the maximum height. Say louder. The vertex, right? That's if it's a sad face parabola, the vertex is the highest point of the parabola, right? That's all they're asking. Find the vertex. How do you find the vertex? Merritt. Yeah. Negative b over 2a. X equals negative b over 2a, which is the formula for the axis of
symmetry.
Right.
And then you plug it in.
All right, so axis of symmetry is the first thing we're going to do. Axis of symmetry, x is equal to negative b over 2a. So negative b is negative 96 over 2 times negative 16. So negative 32, right? All right. So the negative and negative become positive. 32, 3, right? Goes another 3 times, right? 3 times 3 is 9. 3 times 2 is 6. Yeah. So 3 times. So x is equal to 3. That's awesome. So are we done? Let's see. They said find the ball's maximum height. We found x equals 3. Are we done?
Yay!
No, we haven't finished. We need to. We know the axis of symmetry. We know that at 1, 2, 3, there is an axis of symmetry that goes up and down. But we know the vertex is somewhere on that line. Is it here? 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 We don't know. What do we need to know? We know the x of our coordinate, but we need to know our y. So what do I do now?
Plug it in.
Plug it in. Okay. So we've got f of x, meaning f of now 3, because x is 3, is equal to negative 16 times 3 squared, which is 9, plus 96 times 3. Okay? So then we get out our little handy-dandy calculator, unless you guys know these off the top of your head. 16 times 9, I don't know it. Okay, 144. I should have known that. Okay, f of 3 is equal to negative 144 plus 96 times 3. 96 times 3 is equal to 288. Oh, wow, look at that. So subtract 144 from 288. F of 3 is equal to 144. So my vertex, put it right here. My vertex is what? My vertex is what? 3, comma, 144. Are you guys awake?
I'm just writing it.
Okay, oh, I'm sorry. Okay. So my vertex, so we figured out a vertex. So did we answer the first question? Find the ball's maximum height. What's the ball's maximum height? 144 inches, meters, seconds,
Units.
feet.
Yeah.
Right. So our first part, we did number 1. Maximum height equals 144 feet. Okay? Now we got to go to 2. Find the time it takes to reach that height. That's really easy. You actually already figured it out. In other words, that height, here's 144, at time is 3, 1, 2, 3, 144, what's the time it took? From the time you hit it, it took 3 seconds, right? It took 3 seconds. Just draw this a little more, because these are parallel, right? I mean, symmetrical. So it took, number 2, it took 3 seconds for it to reach maximum height. Now the third one, it says, then find how long the ball is in the air. It started from the ground at 0, 0. It took 3 seconds to reach maximum height. And every parabola is symmetrical to the axis of
So 3
symmetry.
seconds to get down.
And it's going to take 3 seconds to get down. So that's a total of 6 seconds, right? So wow, we just solved all of them all in one foul swoop. So it took 6 seconds, it was in the air. 6 seconds in air, right? And then the last one, it says to graph it. Okay, so now we got to graph it. We figured out, this is, well, I just did that sort of ballparky, so let me figure out how to do this.
Should we just do like a line on top and mark it 144?
I think what I'm going to do is, 1, 2, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40. So I'm going to say right here. You can do it by 20s if you want. 20, 40, 60, 80.
Okay, but that changes where your 3 is.
Not really, because I'm only changing the vertical. I'm going to leave my x's the same, right? That's a mistake that people think. They think that they have to, if they count by tens on the y-axis, they think they have to count by tens on the x-axis. Really, they don't. In fact, that's how corporations and businesses manipulate information to make it look like their product is phenomenal, right? Because they will change the way the x and y's are graphed so that it looks like, oh my God, people prefer Del Monte. Look at this graph. Del Monte, they prefer Del Monte over, Kellogg's Corn Flakes, right? Well, from here to here is 3 people, right? Out of 10 billion, right? Or whatever. You know what I'm saying? Like, you can do that. You can make a graph look like, oh my God, I got to buy Del Monte, right? When really, in fact, it's like they're neck and neck, right? There's only 3 people difference, right? Or whatever. But you can graph it. You just have to notify. You have to tell people when you do that we're doing that. And so what you usually do is you write 10, 20, and then or you can say y interval of 10, right? You can do something like that, so people know what you're doing. And then you might, if you're going to do that, you might say x interval of 1, something like that, so that people know that you're doing something weird and different. All right. So we've got 144. Now, what else do we do? We know our zeros. Do we know our zeros? No, we don't know our zeros yet. Well, we sort of do, but let's find our zero. If we found our zeros, we would know where it crosses the x-axis, right?
Isn't our zeros
we already
0 and
yeah, we already know it's 0 and 6, right?
Exactly.
We know that. But if we didn't know that, we could always do this. I just want to show you. Find the zeros. Find the zeros. So that means I'm going to make this equation equal to 0. So I'm going to put the 0 on the right there. Negative 16x squared plus 96x, doesn't look like a 9, equals 0. Now, I do not have a c. Am I correct? I don't have a c. Those are the easiest ones to solve when you don't have a c, because you don't have to do hard factoring. They both have x's. If you don't have a c, everything has x's in it, so you just factor out the x's. And if you want to, you can factor out the 16 if it goes into that. I think 16 does go into 96. Didn't we figure that out?
Yeah.
Like 6 times?
6 times.
Yeah, 6 times. So we'll factor out both. We'll factor out, we'll factor out a negative 16 x, right? And that would give me just an x here. Now, since I'm factoring out a negative, that's going to change this sign. Because it's negative times what is positive? Negative times negative is positive. 6 equals 0. So I have either negative 16x equals 0. Remember, if a times b equals 0. Remember, when you're finding your zeros, I've got factors. If the first factor is times the second factor equals 0, then either the first factor equals 0 or the second factor equals 0. Or they both equal 0. So I'm going to say negative 16x equals 0. And if I divide it by negative 16, I'll see that's 0. X is equal to 0. Or x minus 6 equals 0, which means add 6 to both sides, x is equal to 6. So there we go. We found our zeros. We kind of already knew. And I'm not even going to bother with a well, actually, why not? I'm going to bother with one more. It would help me. Where would it help me to have another dot? Would it help me here? No, Lila, where?
At 1.
At x equals 1, right? If x is 1, it would be really easy for me to plot that, right? So I'm going to just figure that out. Just to find so that I have 3 on both sides to graph a fairly accurate graph, right? You see what I'm doing? I'm choosing something where I want it. I want something either at 1 or 2, when x is 1 or when x is 2. So we'll say 1 because that sounds easy. So, can I erase this? All right, so f of 1. We're going to say f of 1 is equal to that. So we're going to say f of 1 is equal to 16 f of 1 is equal to negative 16 times 1, which is negative 16. And then plus 96 times 1 is 96. What's 96 minus 16? 80, right? So 80. So I know that at 1, so that's going to be another point on the graph. So I go over to 1 and I go up 80. 10, 20, 30, 40, 50, 60, 70, 80. And I put a dot. And there's my graph. I'll reflect it over to, there's my 80 there. I'll draw my graph. Look at that. Right? Pretty easy. Questions? Did I go too fast? I kind of went fast.
Why did you do the 1? Yeah.
Just because see, like on the homeworks in the past of the graphing, I told you there were two things I said. You could use standard parabola guy, over 1, down 1, times negative 16, times 16. Well, I guess you could do that. Oh, you could do that. You could go over 1, down 16, right? That would have been easier, wouldn't it? Yeah, I didn't think of that. Good point. Yeah, that would have been just as easy. You could have gone over 1, down 1 times 16. So go down to 16, wherever that is, and put a dot. And that would have been fine. But the other idea I had was I want a dot somewhere between here and here, right? I have a dot here and I have a dot here. I want something in between. So I chose, I asked, and Lila said, well, when x is 1, it'd be nice to know where the dot is up here when x is 1. That's another way to do it. Or we could have done when x is 2, right? So when you need another line, another dot, you can always get it. Just choose an x that is in that area, right? 1 is such an easy number to choose because 1 squared is 1. 96 times 1 is 96. You know what I mean? There's almost no math. So now the homework tonight will not include graphing. Okay? All it is it's starting to think about maximums, minimums, so forth like that. And so I'm going to turn your page over, and we're going to do one more problem, and then I'm going to give you your homework.
Tonight I get to get the Grand Descension. I'm so excited. Hey.
All right. I think I'm going to just read this. We'll read it together, and instead of me taking the time to write it out, because I'd rather not do that. So it says, a group of friends try to keep a beanbag from touching the ground without using their hands. Once the beanbag has been kicked, its height can be modeled by h is equal to negative 16t squared. Here's our formula again that you guys all know by heart. Plus 2. So that the height of the beanbag can be modeled by that equation. Right? It's going to be a parabola where h is the height in feet at any given moment on that parabola, right? Above the ground, and t is the time in seconds. Find the time it takes the beanbag to reach the ground. What are they asking for? They want it to reach the ground. Time, so find time to reach ground. What are they asking for in the terminology I've given you when we're talking parabolas? What are they looking for?
Peter Griffin.
The ground is the x-axis, right? Most of the time the ground is the x-axis. Every now and then there's an exception. But most of the time the ground is the x-axis. I think there's one problem on the homework where it says the juggler, the juggler's juggling or something, but it says, it doesn't have a 2 here. It says the height of the ball from the juggler's hand. So suddenly the juggler's hand is the x-axis. But usually the ground is the x-axis. In this case, the ground is the x-axis. and the beanbag is 2 feet above the ground when they kick it, right? What are they asking us to find? When it lands on the ground, what is that? When it lands on the x-axis, what is that?
The zero.
Zero.
The zeros, right? That's all they're asking.
Yay!
You guys know these, you could do this in your sleep, right? So find the zeros is really what they're saying. They're not saying find the time it reaches the ground. Find the zeros, right? And that's what we want to find. So, all right. So here we go. We've got this. Find the zeros. So to find the zeros, I make h equal to 0. I want to know what x is when h is 0. H is the height, right? That's your y. So when y is 0. So we're going to have, I'm going to do it with my 0 on the right though. So I'm going to say negative 16t squared plus 14t plus 2 is equal to 0. So now I have to factor this puppy. So the first thing I think of is to factor it to find the zeros. I don't like to have a negative in my a. Well, actually, I have different options. What are the different options I could use on this? Yes.
I was going to say, wouldn't it be easier to just like take the value of the axis of symmetry and multiply it by 2?
No, because then it doesn't reach the ground because that 2.
Like factor out the 2.
Because then you have to somehow figure out how to have that 2. Because look, your parabola goes like this.
Yeah, see,
0 is right here. Your x-axis is right here, and then your parabola starts here. And so all that does is your axis of symmetry figures out this space and then this space, but you don't have any of this space.
So Merritt, yeah.
So if you're figuring out the ground, then you know it's 0.
But wait, no, look. If this were 0, Merritt, you would be right. If that were 0. But it is not. It's starting at 2. Meaning your parabola is going to be at you're going to have a negative 0, right? We don't know what that is. If it started at 0, if it started on the ground, then you were right. You could actually figure out the x. I never even thought of doing that, but that's right. You could figure out the axis of symmetry, your x, and then multiply it times 2, because the parabola will be symmetrical. You're right. But because it starts 2 feet above, you can't. Does that make sense?
No, explain why you can't.
Because look, my parabola, let's say this is my vertex. From here to here is symmetrical, right?
Right.
So from here to here and here to here, I would need to find out this point. I can't figure out. You're saying x. Let me just think about this for a second. Axis of symmetry, x. Yeah, because the axis of symmetry is going to tell you from here to here, not from here to here. And so you need to know from here to here in order to multiply it twice to get to this. If it started at 0, then you would be finding the point from 0 to here, which is what you want.
Oh, okay.
You see what I'm saying? Sort of? So we have different options. We can complete the square. A has to equal 1. That'd be kind of a bummer. I would not want to complete the square in this way. Absolutely not want to. It can be done, but it would be a nightmare. But we could do the quadratic formula. You can always use a quadratic. As long as it equals 0, you can, there's your A, there's your B, there's your C. Now, what else could you do? You might be able to factor it. I'd rather factor it. If I can factor it easily, I'd rather do. I'm going to just look at it for a second.
Half everything and do it?
Well, I don't like this negative. If I was going to factor it, I would multiply everything by -1 and see what happens. I got 16t squared minus 14t minus 2 equals 0. I don't have to, I mean, I could use the quadratic formula, and a lot of people would just immediately jump into the quadratic formula. But I'm just thinking suddenly 16 times -2 is, if I use Gary's terrific trick, remember that? 16 times -2 is -32. -32. Factors of -32 that equal -14. -16 and +2 equal -14. Oh, cool. So I'm going to just do that. Minus 16t plus 2t minus 2 equals 0. This is where people mess up the most. They don't go back to see, does this equal this? -16t plus 2t, -14t. Yes, it works. Once you know that, then we keep going. So we'll do our factoring by grouping. 16t, I have t minus 1 plus 2 times t minus 1 equals 0. So I have either t minus 1, well, I have t minus 1 times 16t plus 2 equals 0. You with me? Oh, I'm sorry. I apologize. So all I did is I found what equaled my factors that equaled negative 14. I rewrote it as a 4-term problem.
Why do you have to use T?
Just go like this. Put a little tail on it so that it looks like a T as opposed to something else, a plus sign. You don't want it to look like a plus sign. T. A lot of times people use T because it's time, right? And it just makes it easy to remember something. And then I factored by grouping. I got 16t times t minus 1 plus 2 times t minus 1 equals 0. And then, so those are my two factors. So either that equals 0 or that equals 0. So either t minus 1 equals 0, meaning t is equal to 1, or 16t plus 2 equals 0. So I'm going to subtract 2. 16t equals negative 2. Divide by 16. Divide by 16. T is equal to negative 1/8. So this is negative 1/8. Not. This is going to be right here. My 0 is right here. So Merritt, you would have been close, but you would have been a little off. Right? Whoops. Jeez. You got the idea, right? So, so I know that my time, what is my time here? I know here it's negative, right? So that's going to be negative 1/8. Here my time is, the other one I figured out. Time is 1 second. So 1 second is my answer.
What?
1 second.
Okay.
Yep.
Oh no.
What is this? I forgot what the problem was. Yeah, beanbag, right? Kicking a beanbag. 1 second.
How do you know it's cold?
Oh, because it's modeled by this equation. So we just found this. Oh, how do you know? Because we factored this to find the zeros. My zeros are either t is equal to 1 or t is equal to negative 1/8. So it crosses the x-axis at negative 1/8 or at 1.
So it's 1 second and 1/8.
Negative time doesn't make sense. So you have to do it.
Yeah, you can't have a negative time. Time starts at 0, but it started 2 feet up. It starts 2 feet up. That's the reason it's time that has a negative number, right? So your 2 feet up is your y-intercept. That's always your y-intercept. Am I losing you?
But you can't have a negative.
Right, you can't. But you're solving for the zeros. Then one of the zeros is a negative. It doesn't make sense in real life, so you're right. That's not the answer. The one that makes sense is the answer. T equals 1. Time is 1 second. In 1 second, the beanbag, after I kick it, will hit the ground. If it follows that particular parabola. Does it make sense? All right. So that's basically it. And then the homework is going to be a bunch of problems that are all really they're going to be asking for is 2 things. Finding the zeros or finding the vertex. That's it. Finding the maximum height of the ball. Or can the sailboat, if it says a bridge. So watch. If you have a bridge. Right?
You have a bridge. Second egg.
You have a bridge over the water. And this right here, this parabola right here, is something. And they tell you what that parabola is. And they say, can a sailboat that's 24 feet tall, the mast is 24 feet tall, can it pass under this bridge? So what would you need to find? The vertex, right? If you find the y of the vertex is bigger than 24 feet, you just answered your question. Yes, of course the sailboat can get through there, right? So that's all they're asking is what's the vertex or what's the time, or what's the zeros, right? Okay, that's the homework. So I'm going to if you have to use the quadratic formula, just anytime they're hard, just use the calculator.
That would be so sad if you had to. No, please stop.